Hey guys, okay, so in the last video, you guys should have created the parts for this particular toy that I made up, in which now we're going to have to put together. I renamed the parts of the toy on the bottom left-hand corner. As you can see, this is called the toy legs, which is just that rectangle. If you want to rename it yourself, you can just right-click it and then select rename and change it to toy legs. This is what I call the toy top, which is the one with the hole in it. Again, you could always right click and rename that. And then this cylinder shape is what I call the toy peg. Again, you can right click and rename that if you want to. Once you guys have your document, which I call toy, as you can see on the top left hand corner, I called it toy. Um, every single time you guys create shapes or parts in OnShape, it'll give you an assembly file, which in this case, we don't have anything there because we haven't really assembled anything. Now we're going to actually assemble it or put it together. What you want to do is you want to limit the degrees of freedom. So we talked in class about that there are 6 degrees of freedom, right? Up, down, left, right, front, back. So now we're trying to put it together and limit the degrees of freedom for this particular object so that it does not move in three-dimensional space. That little dot right there is actually the origin for this particular space. And we could actually use the origin to constrain our part to it once we're actually done, moving stuff around and constraining our parts that we need to. So first thing we need to do is insert a part, whichever one you guys want. I'm going to go ahead and insert, let's go with the toy top, and anywhere you guys want. Once you left click on that, it'll insert it. As you can see, this is my toy top here, right? So wherever you guys want. Now, I'm also going to insert my toy legs, or actually one of them. And again, wherever you want to set that down, you can go ahead and click. And now you have two things that we have to put together that we need to constrain. Okay. So I don't want the peg there, so let me just get rid of that. So you should have these two for now. All right, so now what you're going to be using primarily is the planar constraint, which is the one here that looks like a plus sign. It kind of looks like X and Y axis. So the planar constraint will actually either align the two planes together, meaning like put them on the same plane, either because they're a little offset, or it'll put the faces of the planes together depending on which planes you actually select. So let me give you guys a really quick example. So let's say I wanna put the leg on this little table here. So I'm gonna go ahead and select the planar mate, and I'm gonna say that this bottom of this toy table or toy top, so that'll actually select this plane, right? So notice that it colored in yellow. There is a normal little arrow pointing down, meaning that it's waiting to be connected to something, whatever plane you select. I'm gonna go ahead and say that this is the side that should be connected to the bottom of that table. So once I select that, it'll actually rearrange itself into the orientation that it needs to go. Now notice that it is going to look a little bit funky in the beginning. That is normal. I'm going to go ahead and select the little check mark. And on the left-hand side, you'll see that you have a little exclamation mark. The top left-hand corner of your keyboard, you have the escape key. That is your best friend. Push escape, and then that'll go away. Okay. So now, as you can see, I put one constraint so far, so I've limited only 1 degree of freedom, meaning like if I look at it, let me look at it from the right side, so I'm going to double click here. If I look at it from this side, I can only move this left, right, and up, down, right? But notice that I cannot move it in the other direction. So if I look in this isometric, I cannot move this in this direction because it's already constrained, so they would actually move together. Because if you remember, those two planes are actually connected together for this particular part so far. But I want to limit some more things on it, right? So I also want to make sure that it doesn't move, slide around, because this is not a pretty safe toy to do so. So I'm going to go ahead and put another planar constraint. So what I'm going to do now is I'm going to say, okay, now that I have that leg kind of sort of where I want it, but not really. Or actually, you know what? I think I messed up on that first plane. So I'm going to go ahead and delete that because what I can see is that I actually selected this face. Actually, would it work? Yeah, it'll work. Okay, never mind. What I'm going to do is I'm going to go ahead and bring this leg down. Or actually, would it work? No, I don't think it would work. So let me go ahead and redo that really quick. So I'm going to delete this and try again. So I want this to be the bottom, right? So if I do that, let me try the planar mate again. So this bottom of the table, which again, be very careful when you click stuff because sometimes it'll give you something that you don't actually want, which is what happened to me. So let's see if it did it this time. There you go. It highlighted it. So that's the one that I want. So that's the bottom of the little tabletop. And then that'll be connected to this face right here. And I'm going to go ahead and select OK, escape, and it should be at the bottom of the little table here. Now it's on the right face. And now if you notice that degrees of freedom are limited, so now I can only slide it around. I can slide it forward, backwards, but I cannot move it away from that plane. So if I turn it around, you'll be able to see it a little better, right? So I can slide it. I can move it in different directions, but I cannot move it away from that plane. Okay, so now we're going to constrain it just a little more. What we want to constrain now is another planar constraint. We're going to be using a lot of planar constraints for this assignment. So I'm going to go ahead and say, okay, so now that I have the bottom of the table, I'm going to constrain I'm going to have the little leg turn so that it is actually, well, you'll see what I mean in a little bit. I want actually the bottom of, or this plane right here, which is the side of the leg, that should be coplanar, meaning on the same plane as this side right here. So let me get on the other side because it's kind of being annoying. If at any point you want to zoom in because it's kind of being annoying, you could always do that. Okay, I'm going to select this plane right here and okay. And let me zoom out so you guys can see what it is that I'm talking about. Let me zoom to fit. Okay, so now escape so it doesn't give me any issues. And as you can see, I can move this. Actually, I think it's pretty much set. So seems to be like I can move it in only one direction. Let's see. It's kind of hard to see from this angle, so I'm going to try to turn it so you guys can see. Okay, there we go. So I have limited the degrees of freedom, right? So now I connected two planes together. So I did the top of the leg to the bottom of the table, and then I constrained the planes to be like the side here. So this is constrained to that. So now they cannot move. The only way that I can move it is forwards and backwards in this case, but I don't want that to happen either. Okay, so I'm going to add another planar constraint. So this time I'm going to be zooming in. Okay, let's try it. Got to be careful. I don't have a little mouse wheel, so it's kind of hard to zoom in with my fingers. There we go. All right, so I'm going to say that this plane right here should be connected to this plane right here. And what I mean by connected, I mean it should be coplanar to this plane right here. So when I select those two, it's going to look funky again, like what I mentioned earlier. I'm going to select OK. And now everything just satisfies once you select OK and hit escape. Basically everything should be where it belongs now. When I select zoom to fit, if I turn this around, you will see that this is actually now the leg of this little toy table or whatever. So now we just have to do that on the other side as well. If you notice, if I try to move this around, I can't, right? Because now I can move it. I can move it if I move the whole thing around, but I can't move the leg by itself because now it's connected. I made these two planes be connected together or coplanar to each other. I made these two faces be coplanar to each other, and I made the top of the leg to the bottom of the table be stuck to each other. So now I can't move that around anymore. So if I go ahead and select insert and I put another toy leg down, I'm going to put it on this side now. Now I can actually work with this. So escape. Oh, my bad. This escape key is good for some things and bad for others. Okay, I have to select the green little arrow that I actually want that. All right, so let's do this again. Again, we're going to use a lot of planar mates. So the first thing I want to do is I want to say that this plane right here, which is, whoa, this plane right here should actually be coplanar, meaning on the same plane as this right here. So this side of the leg. If I do that, it'll turn itself. It'll look funky, like I said. It's okay. Just click the little arrow, and then it'll actually reset itself once you actually select that you're actually okay with that decision. Hit escape. Once you do that, notice that I can actually move this around, right? I can actually move this up, down, left, right. if I wanted to, but I cannot move it away from that plane. I cannot move it forwards or backwards anymore. So now we just have to constrain it 2 more times, kind of like what we did for the last time. So if I click on the planar mates, now I want to connect the bottom of that table. So let's select, let me zoom in so I know that I'm doing the right plane, so it doesn't mess up on me like last time. So that should be the bottom of the table. Hopefully it did it correctly. There we go, it highlighted it. So the bottom of that little toy table, I'm going to connect it to the top of that leg, and then select that plane. Once you do that, select the green arrow, again, escape, and now we have 2 constraints, 2 planar constraints. If at any point inside of view, you could always select, again, zoom to fit, and then it'll go back to that so you could actually see what's going on. Notice that I can move the little leg. Wait, is this the right one? I think this was right. There we go. This was the one that I was working with, because this is the one that's actually moving around. So notice that I can move the little leg in only 2 degrees of freedom now. So I can move it to the right or to the left, according to my orientation, but now I don't want that to move at all. So now what I want to do is I want to get it stuck, which means that I want to constrain the planes. So this side of the table, of the tabletop here, let me zoom it in a little bit. There we go. So that side of the tabletop should be coplanar to this plane right here, which is that side of the table leg. And again, it's going to look funky. Once you select that you're okay with it, it'll go back and rearrange itself properly. So zoom to fit. That way you can actually be able to be seen. And now escape. And what you notice is that this thing actually is able to be moved, but it can be moved together as one single unit. So now, obviously, in 3-dimensional space, you don't want this to be like moving up like every direction, right? So you actually want to constrain it to something, and that's actually why that little point is there to begin with. That little point is a point in space that you could actually use to constrain things to that point. So you could use what is called on the left-hand side a Fasten Mate. So now let's say I don't want this to move around, right? Because I'm gonna put the peg in there somewhere, and I don't want this moving around. So if you select the Fasten Mate, which is the very first constraint that you should see, what I'm gonna do is I'm gonna select that point, and I'm gonna fasten it, or basically get it connected or stuck to. Imagine if it's like bolted down. I want to get it bolted down to this corner right here. Just pick one. I'm gonna go with whichever one. Let's go with this. Again, it's going to look funky, kind of like all the other ones. If you select the little green arrow saying you're okay with it, it'll rearrange itself, and it'll actually be stuck to that point. Let me show you what it looks like in zoom to fit. Notice that the point is actually there on that little corner where I put it. Let me put it on isometric view so you can see. And you could always turn this around if it bothers you, or rearrange it however which way you want. But the important thing is that the degrees of freedom are not there anymore. This thing cannot be moved. This is actually fully assembled. All we need now is the peg. So let's put the peg down so we could actually insert it. So I'm going to go ahead and select Insert, Toy Peg, and drop that down anywhere. And once you're happy with how many of those you want, you just select the little green arrow. All we got to do is we're going to drop that peg in that hole. For that, we will need one of the constraints, which is called, I think this is the cylindrical mate. I think this is the one that does, or actually, let's go with slider mate. Slider mate is the one that actually, because that's exactly what we're going to be doing for this peg. So I'm going to select slider mate. Basically, this peg is supposed to slide in and out of that little hole there. So I'm going to select the middle of the peg, the center. Basically, there's a line going through the center of that cylinder. So select that center. And I'm going to also select the center of this hole. And then once you do that, if you select the little green arrow, now we limit the degrees of freedom, because what we did is we actually made those 2 center lines collinear, meaning that it cannot go anywhere besides on that line. So those 2 center lines are exactly the same for the hole and for the cylinder. The only thing that we can do with this little peg is we could actually still slide it, because that's why it's called the slider mate. It actually makes the 2 lines to it collinear, right? But we could actually still slide it up and down. Now, the last piece of the puzzle, if you don't want it to slide up and down, if you want that to be just for the purpose of this activity, if you want that to be stuck or go planar to the top of the leg, I'm going to go ahead and do one last planar mate, meaning I'm going to go ahead and say that this top of the cylinder will be coplanar to that surface, which is the top of the table. And once I select that and I select the little green arrow, now I have my fully assembled part, which is this little toy that I made up. Again, this is just for you to practice. What you guys are actually going to end up doing, well, besides turning in this particular assembly, is you're going to be assembling your cubes in the future. So I hope this was helpful. Make sure that nothing moves before you turn it in. Have a good one.